Say it again?
For that answer.
No, for that answer, no, you weren't required to write how many half-life. I was just a question.
I got it.
What? Yeah, that's it for notes. I made them short today because I wanted to be able to go over the test.
Well, first you have to tell yours, right there.
Well, I did all that.
Right.
What?
They may not get their test back.
Holy cow, I did good.
Good.
18 and a half.
Okay. So, let's look at the first page. Okay, so are there any questions on the first page?
Number one.
We're going over each page separately.
Number one. Can I go to C-sharp one now, please?
Oh my god.
Don't let 'em.
I literally.
I said please.
Still.
But we're still in class, though. He doesn't expect you to leave class.
No, that just means not.
Okay, he's going to ask Ms. Comrie if she says yes. Then you know. Okay, so number one. So we have f of x equals so what do we need to do first in this problem? What do we need to find? The zeros, and then what else? The undefined terms? Okay, so what are my zeros? The top or the bottom? Okay, which ones are my zeros? The top or the bottom? Top? Like when is the function going to be 0? So we should have x equals 7 over 2 and x equals -3 as the two zeros. Kind of flipped around? Like you did -7 over 2. Oh, okay. And then this where it's undefined is when the bottom is 0. Right? Because that's also if the bottom is, when it's undefined, there's a what? Asymptote. Good. So that's when, so these are potential sign changes. Then we make a sign chart. So then here, what you have to do is plug in a number within these intervals into here and find out whether it's positive or negative. And so your answer should have been what? Did everybody get it right? D? Right? Good. Okay. So what else on this first page? Anything else? So this one, so if we look at number 2, I'll show you how to set it up. I'm not gonna go through the whole thing. So if we have imaginary numbers, what do we always know as one of our zeros? Who knows? If we have an imaginary number as a 0, what do we also know? That what? Nobody knows? Some people got it right on their test.
Wait, what? What number?
What do we know about imaginary zeros? They come in pairs. Did you say it quietly? So for this one, it's I, so we're gonna have x plus I and x minus I. So you do these ones first, and your middle terms are gonna cancel out, and then you do that by this. So you're gonna have x squared, and then you're gonna have minus IX. What? So it's saying if you plug -3 in, you get 60 out.
Yeah, you didn't really.
So it's another way to check your answer. What?
Yeah, you really didn't need the imaginary zeros, I think it's just what you read all those.
I would agree, but you could have done either way. Yep. You should have gotten this and multiplied it that. So those would cancel out. Okay. And everybody gets the the behavior of the asymptotes. Everybody's good with that? On number 5? Yeah? Okay, so let's move on to the second page. What do we need to look at on the second page?
Number 8.
Number 8?
Now, you might have.
I got -3, so I guess it's completely wrong.
I don't know.
So we have so if we have something like this, what do we always know we have to do first? Factor it. So what does the top factor into?
-4
X minus 4 and x plus 1. And then what about the bottom? X plus 5 and x plus 6. So now we do the same thing. Oh. So we do the same thing that we did on the other problem, we make a sign chart. So we look at and see where our potential sign changes are. Yeah, that's another answer. But so, how many potential sign changes are we going to have then? Wow, it is just really quiet in here today. The rain is making everybody tired. So. Okay. So we're going to have 4 different potential sign changes, so we're going to have 5 different intervals we have to look at. So it's going to be -6, -5, -4, and -1 and 4. Okay. So then do you guys know how to do it from there? So we plug in a number from the interval. So from -infinity to -6, so pick like -7. So we have -7 minus 4 is negative. This is negative, negative, negative. And so this is going to be what? Positive. So positive, or the top becomes positive, so negative times negative becomes positive. So 2 negatives. So you have to do that for all 5 spots. And so the correct interval was from -6 to -5, and from -1 to 4.
Yeah.
Yep. What? -5. So this interval and this interval are the ones that are less than 0. So that's what you're looking for in this one. We're looking for when the function is less than 0. So we're looking for when they're negative. Okay. Anything else on that page? No? Okay, so let's look at the last page. Did you do the word problem one? No? Yes? Would you like me to go over that, or no? Yeah? Okay. So, the first one says, we're looking at rectangles with an area of 256 centimeters squared. So, if this is our area, and this is our rectangle, how would we write the length of the side? If this is our area. Yeah, so it says, it even gives you a hint, it says write one in terms of x, and so then the other one's gonna be 256 over x. And then it says, we need to express the perimeter as a function of x, so we already have both of our terms. And then we need to find the dimensions of the rectangle with the least perimeter. So how do we use this information we have here to find out an equation for perimeter? Yeah, 2x plus what?
Or 2.
Yeah, 2 times 256 over x. What? Equals, I'm just writing p of x because we're talking about the perimeter. So this would be the equation for the perimeter in terms, since we already found out what x and y, or what like the length and the width were in terms of the area, then we can plug that in for this, and so we only have one variable. And so now what do we need to do? If we're going to find the least perimeter, we find the what? Nobody knows? So we graph it, and we find the minimum. So we want to find where the perimeter is the smallest, or the least perimeter. Okay. And some of you just wrote, like, it can be a perfect square, but, or maybe, oh, Miss Connery said it yesterday, but, like, you got marked off a little bit if you didn't write it in terms of this, since it's something you should know how to do.
I just write that, and I wrote the way for me to read whatever I had to do.
Okay, I can look at it in a minute. Okay. So you should have gotten 16 by 16. So what's a square? You should have been able to find that without just saying that the least here or the least is a square. Okay, so you want to find a rectangular enclosure with the area of at least 100 yards, 1,000 yards. So how would we write that? If it's saying 1,000 yards squared, it says at least that. So what do we need if it's saying at least? Like an equal sign? What do we use? Yeah, 1,000 is less than or equal to, and then our area formula, which is length times width. Okay, so that was one part that you need to have. And then it says 140 yards of fencing is going to be used. And so it's saying what limit does the width have to lie in, which is going to bring us back to this one.